Alrighty, welcome. This video is the Introduction to Complex Number video, and it goes along with the worksheet. So the first thing we're going to do is we're going to go ahead and review a little bit about the need for complex numbers, but let's go ahead and just review some regular equations. So each one of these equations, what you'll see here is usually a instructions to solve. Anytime you are solving an equation, you're going to look for what am I solving for? In this case, we're solving for an unknown in x. And in every one of these equations, we see x only occurred once. So what we can do is we can undo everything around x so that we eventually get x equals to something. And the way we undo is we always use the inverse operations in reverse order. So let's look instead of all of these, and by the way, all of these have the same answer. Let's look at the last one. So if I looked at x and I said this was a function and let's let x equal 5, evaluate. So we would plug in 5, but what would we do to 5 first, or that value? The first thing we would do is square it. Next thing we would do is subtract 2. Next thing we would do is multiply by 2. Then we would add 4, and then finally we would divide by 2. So when we go to solve this, it's basically like unwrapping a present. If you're going to go give a present, you go get it, you wrap it, you put a bow on it, you put a card on it, etc. If you receive it, you're going to do the opposite in the opposite order. You're going to undo the card, read it, you're going to undo the bow, you're going to undo the wrapping paper, and finally get the present. So this is kind of the idea that this is my steps in order to solve this. I'm going to undo divide by 2. So I'm going to multiply everything by 2. So I'm going to end up with 18 here. Next thing I'm going to do is, instead of add 4, I'm going to subtract 4. So I'm going to subtract 4 to both sides. So I'm going to get 14. Next thing I'm going to do is divide. Instead of multiply by 2, I'm going to divide everything by 2. So I'm going to end up with 7 now. You can see I'm kind of just really quickly going through this, but you get the idea. And then finally, the last thing I'm going to do is, or excuse me, second to last thing, I'm going to subtract. Instead of subtracting 2, I'm going to add 2 to both of these, and that's going to undo that. And then finally, I'm basically left with x squared is equal to 9. All this is 9. I know this is a little bit confusing, but you get the idea. So we have x squared is equal to 9. And finally, in order to undo square, we all know it, we use the square root. Now, when we undo a square root of a squared, we don't know whether this value here was positive or negative. So when we take the square root of this, we have to do the principal and the secondary square root, because we have both positive 3 times itself twice gives you 9, and negative 3 times itself gives you 9. So there are 2 answers. Now, if you have a question like this, just look. If I'm solving, x is in 2 different places, but it is of the same likeness. They're both x squared. So I can add an x squared to both sides, and I get 2x squared is equal to 18. And once again, I could divide by 2. X squared equals 9, square root of both sides, x is equal to plus or minus 3. This is shorthand for that. So that will get you hopefully through the first page. So let's look at the back side. On the back, this is the new stuff, okay? And where this arises, if we have an example like this, well, we could take the x squared. Well, what happens if we eventually had a negative number over here? Sure, we could take the square root of both sides and this would undo each other, but then we would have the square root of a negative number. Well, 500 years ago, they didn't know what to do and they just stopped, so it couldn't be done. But within that time frame, we've introduced a couple definitions. Definitions you just have to memorize. I is equal to the square root of negative 1, and I times I, or I squared, is equal to just negative 1. So I is irrational while I squared is rational. So let's look at a couple examples over here. What is a complex number? A complex number is written in general real and an imaginary part, where a and b are both real numbers. So here are a bunch of different examples. 2, 3, 5, 0, 0, negative 8, radical 2, 3 are all real numbers. So basically, anytime you see a complex number, complex numbers could look with real and imaginary part just 100% real, pure real, pure imaginary, some irrational in there. So basically complex numbers is every number in the entire universe. So let's look at some adding, subtracting, multiplying, and dividing. Actually, before we do that, let's look at some quick stuff on, well, what happens if I had negative 81? How do I simplify that? Remember, we can split up a negative into negative 1 times 81. Same root I can multiply, so I'm basically just making it look a little bit more complex. This is I, and as we all know, square root of 81 is 9. Now, normally we write the known number first and then the I later. All right, so now let's look at adding, subtracting, and just multiplying, and then the next day on Monday or Tuesday, we'll look at dividing. When we're adding, subtracting, or multiplying, treat it just like x, except when you have powers, you'll see I squared, or in this case, if you were to substitute for x squared, I squared is going to equal negative 1. And it's kind of pretty easy once you get the hang of it. So 2i plus 5i is just add like terms is going to be 7i. Easy enough. 3i minus 7i is going to be negative 4i. So this is easy. Now let's look at something a little more different. So we have both the real and imaginary part of both, and we're subtracting. Now adding I didn't go through, but it's kind of the same idea. When I'm subtracting, remember to go ahead and distribute this negative. That's one of our major issues that we see. So now we're doing 3 plus negative 2, 1. Ugly looking one. And then 5 plus positive 3i will get me to 5i. So that's sure enough how to add and subtract. Now when we multiply, just go ahead and multiply our known 5 and 2. We'll get 10. Now I times I is I squared. But remember, any power higher than 1 of I, we have to simplify. I squared is just now negative 1. So 10 times negative 1 is negative 10. Over here, when we have something like this, we need to go ahead and distribute, FOIL. So we're going to have 3 times 2, 6. 3 times I, 3i. Now let's look at the other distribution of negative 5i. So negative 5i times 2, negative 10i, and now negative 5i times I is negative 5i squared. Now you should end up with 4 terms, and I say this is real, imaginary, and gonna be real. Why? Because this I squared is negative 1, and all it basically does is change the sign. So we have 6 and a positive 5 here, since I have a double negative for 11, and I have 3i minus 10i to give a negative 7i. And then finally something like this. If we have something like 2 minus 3i squared, just go ahead and rewrite it twice. Remember that the power of 2 means the same thing multiplied by twice. So when we FOIL this, we're going to have 4, and then when we go here, negative 6i, here, negative 6i, here, positive 9i squared. So all of this I squared is going to turn the 9 into negative 9. So 4 and negative 9 is negative 5, and negative 6 and negative 6 is negative 12i. You should never have any higher power than 1 of I. And that's the video. Hopefully you can complete this worksheet. As a bonus, if you had watched this the night before, within the first 5 minutes of class, if you tell me your favorite color, first person in each class to tell me your favorite color, you get 5 extra points on your quiz.